Hello there. How are you doing?
Oh my God, it's actual Tom Scott off of YouTube,
See, the trouble
but
is,
on YouTube.
you said join this 5 minutes early, and I did. And I'm no, I haven't tweeted this out yet. You're going to have 5 minutes of me doing admin at this point.
Well, fine, that's all right. I can keep chatting if that's helpful. So, yeah, so Tom's here, and so you're a YouTuber, I guess. You're a person who
I
does YouTube
guess.
videos.
Yeah.
Yeah.
I always
No,
feel more comfortable with the longer description there. Like the one word doesn't seem to sum it up right.
I mean that in itself is like a million jobs, right? Because people, oh, you just a person who does YouTube, yeah, but that means you're a presenter, videographer, filmmaker, producer, director, script writer. I mean, there's
Yeah.
all these jobs that are involved in that, and kind of you've been doing this for a long time on
Yeah,
YouTube, and you've got
about 14 years now, technically. But yeah,
that's
the
incredible.
the regular videos for about 5 or 6. But yeah.
Yeah. And I mean, I've seen a whole bunch of your videos. There's so many interesting topics in there. I said at the top of the show, we would have people who are mathematicians and maths adjacent. And I feel like I don't know if you would put yourself in that
Oh,
category.
now
Because you do a lot of computer science stuff, right? You do lots of technological.
I do. I've made one appearance on Numberphile in my time. But
I mean, haven't we all? Everyone's done one Numberphile video, right? Yeah.
I mean, I was never much of a maths student. Like recreational mathematics is one of those things that sounds very fun to me, but which I never really got the hang of.
Well, I mean, maths is a thing. This kind of myth that people who do kind of popularization of maths, like me, we're always trying to sort of make everyone feel really comfortable with maths. But there's a secret that we all don't tell people, which is maths can be really difficult. There's a lot of stuff around it that is, sometimes a bit boring, maybe quite difficult. And the thing that we try to do is to sort of pick out interesting things to share with people. But actually, I think it's the Matt Parker, who apparently is just ubiquitously mentioned in every slot in the show, it's what happens, isn't it? Once said that mathematicians are not people who find maths easy, they're people who enjoy the fact that it's difficult.
Yes.
And I think that's the thing. And a lot of people struggle with maths. A lot of people find it difficult or don't necessarily engage with it. And I think it's a shame because there's a lot of fun stuff to be had in there. So I've brought along a maths trick to show you, since that feels like a bit more of a sensible combination of things. We just had a comment in the chat.
Let me just give me a moment. I'm just going to tweet out while you're dealing with the chat. I'm going to actually tell people that this is happening for the next half hour.
Okay, fine.
So.
Someone has pointed out that they've spotted a connection between the two people who are on the show at the moment, which is that we have both been on Only Connect.
Yes, although I suspect
as people who've been on Only Connect, we should have spotted that, right?
I suspect that's true of a lot of people who will be on, because I think they're on season. They're in double-digit numbers of seasons
16, now. I think, is the one that that's just.
So I would be very surprised if we are the only Connect. You know what? Not just the only Connect players. I'd be surprised if we're the only captains on this stream. Like there will be more.
Wow.
I'm pretty sure.
Maybe so. I've not kind of gone through thoroughly. So for anyone who's not aware, this is a UK TV quiz show, which is, I think it's got a reputation as being quite a sort of difficult quiz, I guess. But it's named after a quote from, I think, E.M. Forster about Only Connect something. That's my level, basically. I don't know if anyone's seen, because one of the episodes that I'm on has already gone out, and the next one's going to be out just before Christmas.
Without spoilers, that is a very difficult show, and like I was, as someone who's been watching that show for a long time, like congratulations, it was a good performance. I'm not saying whether you won or lost. I'm just saying like you came out of that acquitting yourself well.
Yeah, well, I think because the way that this tournament's structured, it's double elimination, which I believe was invented by Lewis Carroll.
It's one of those modified double elimination ones where you have to lose twice or lose in the final playoffs, which makes a lot of competition pedants very angry, but which is great for running a series. But it's this balance between making the show work and making the competition perfectly fair, which is always like a balance when you're doing something for broadcast.
Well, yeah, that's the thing, I guess, because it's done as a sort of tournament in two halves, and you'd end up with two teams that get to the semi-final, that get to the final and play against each other. And it's like, is that necessarily the two best teams? Like, would one of those teams have been beaten by one of the teams that went out earlier? But I'd like to think that that sort of double format where you get a second chance if you lose, you just might have been up against a really difficult team, kind of makes it a bit fairer for the show. But anyway, if you haven't seen any of the show, if you're in the UK, it's on BBC iPlayer. If you're elsewhere, I imagine you can probably find, there's certainly clips of Tom's episodes from
there's clips of all of them, something. I think.
Yeah.
How on earth whoever's uploading every episode of the series is getting away with it, I have no idea.
It's not really clear. Yeah, but there are quite a few episodes available to watch if you look around for them. So yeah, that's a connection. Good spot, everyone. So I said I told you I was going to do a trick. So I've brought along. It's not. I was going to try and find something slightly computery for you, but I think I've brought something that's a bit more sort of general.
You told me to bring some sheets of paper and some scissors. So I have. Excellent. If I hold the paper there, it completely ruins the lighting in the shot. I have some A4 paper and I have just a big camera-friendly pair of scissors, biggest ones I could find.
Perfect. So I might set you a little challenge with that in a minute. So this is
by the way, before we do the trick thing, because keep them watching. Always front load the conversation. How are you doing? Like this is our number 10. For you, I think.
Thereabouts, yeah, something like that.
Are you hosting the entire 24 hours of this?
I'm not. So we've got a rota of presenters. So every hour and a half we switch to a new presenter. Although I have been doing bits of behind the scenes stuff. So I was here for the first couple of hours. I then did a bit for Mark Watson's show, which is running at the same time. And because they had, I think Judge Rinder was on there and just kept talking for like half an hour. So I got pushed back and back and back. So I ended up on there about an hour later than I was supposed to be. I did that bit and then I went to sleep and I slept for 3 hours and then I woke up and then I started doing behind the scenes again. So I'm doing okay. I'm going to power through until 9 p.m. tonight. I can legitimately say tonight now because it's about to be, the sun has come up. That's weird. Okay. That's news. I didn't even notice. I'm hoping it'll be okay. We've got a fantastic team behind the scenes. There's people in the chat moderating. I have to say, this is the most wholesome chat moderation I've ever seen. Like 90% of the moderating that's happening is people removing spoilers for puzzles, and the rest is there's a very small amount of people actually properly moderating, but this is really nice. So I can to reiterate, this is the Maths Magic show, so I'm going to show Tom some interesting mathematical tricks, and this is kind of a piece of maths which I discovered a little while ago. I got really interested in this because I was doing some work which involved cutting out a square. So this was, I had like a square on a piece of paper and I had to cut out a square shape. And just to be clear, this was literally my job. Like this is how my job works, is sometimes it's all about having to cut out some squares. And I needed to cut out the shape, but I didn't want to sort of cut in from one side and then cut around the square, because I didn't just need the bit in the middle intact, I needed the whole intact as well. And I thought, okay, well, I can get my scissors, I could maybe stab a hole in the corner and cut round, but it might look a bit kind of scruffy. So I thought, what if I fold the piece of paper in half like that? So I can do that. I can look through that up to the light. If there's a light source in here, there we go. And if I line that up, I now can cut 3 sides of this square, and it will cut out the whole square, right? And this is nice. So I was about to pick up the scissors, and I thought, hang on, I can do this more easy. I can make this less work for my scissors, right? So if I fold this again this way, I can line up those 2 edges there. And now, instead of 4 cuts, instead of 3 cuts, it's now 2 cuts.
Right.
Which is, I assume, as efficient as I can go with this, potentially. But then the small mathematician in the back of my head popped in and said, nope, we can do better than that. So I realised that, everyone at home is already thinking this, but hopefully somewhere in there is the word diagonal. I'm going to do a diagonal fold like that.
Should I be following along with this, by the way? I'm just...
No, that's fine. Yeah.
Okay.
Yeah. So I've got my folded up bit of paper, and if I now do one nice straight cut like that, and unfold this, we'll see that I've cut out the whole square in just one cut, right? And that's impressive. That's an impressive feat. I've just used one cut, and I've also still got my square hole as well. Like this is still there, right?
It's one of those things where, like, as an arts, like doing arts and crafts as a kid, yeah, of course, you fold the paper in half and you cut it out. Never thought of folding it twice. No idea why.
Well, this is the thing. But so the thing that mathematicians often do is just take things to their absolute logical extreme. So having reached the point where I can do one straight cut, I was sort of pleased, right? It's a minor achievement in life. I felt good about myself, and I happened to be going to the pub that evening to meet up with some mathematicians, because that's what I do.
And it's where a lot of good ideas happen.
Yeah, this is where all the best maths happens. And I said, have you seen that you can do this with one cut? Isn't that neat? And I happened to be talking to a mathematician called James Grime, who may be familiar to some people.
I was at the same university.
YouTube.
Different timing, but yeah.
Yeah, may or may not be joining us later on in the show as well. And James said, isn't that a theorem? And I was like, is it? That's really interesting. And it turns out
I can picture James saying, I can hear James saying that in my head. I kind of know the manner in which he
Yeah, exactly. So he was like, isn't that a theorem? And I couldn't believe this. So I looked it up, and there is a piece of maths, and it's called the fold and cut theorem, and it's basically some mathematicians who've explored what the options are, what the possibilities are for shapes that you can cut out with one straight cut. So if you've got a piece of paper, you're allowed to fold it as much as you like, do as many folds as you want. Yep. What possible shapes can you make? And this is kind of an interesting question. So they've done a paper about this. There's a mathematical paper.
Can they fold it and then get the result? No, sorry, that was.
That's the question. Yeah, it's folding and cutting paper.
I regret that joke. Were this not a live stream, I'd have cut that joke out.
To be honest, if I was really on it, I would have printed a copy of the paper and be using that for all of my folding and cutting. But there are things that you can fold. So I've just folded up this piece of paper here that actually kind of turn into a bit of a magic trick. And this is actually a trick that has been done on stage by Harry Houdini, actual magician, which is to say, make a fold in a piece of paper like that. I've just done a bunch of folds in this one, cut that, and you can get a nice 5-pointed star.
Oh, lovely.
Quite a nice little trick, isn't it? Yeah, and there's all kinds of little stories around this.
Work out how to do that?
So that is the question. And in this paper, the mathematicians that did this basically worked out how to come up with a fold pattern for whatever shape you wanted to cut. And it turns out once you've got whatever shape you give me, I can fold it. That's the theorem. Any shape, as long as the edges are all straight lines, any shape can be made with a sufficiently complicated pattern of folds. And there are obviously physical limitations on this, because mathematicians are thinking about this in the sort of notional abstract universe where everything is infinitely thin and you can fold paper as many times as you want, and this, that, and the other.
Yeah, spherical towels in a vacuum, all that.
Exactly, so you can, in theory, fold a piece of paper into any, so that one cut will make any shape at all. And I've kind of come up with a little trick around this. So in the paper, they mentioned that there is a person that they had encountered who can fold any letter of the alphabet on demand. Okay. I thought that would make a really nice trick. Maybe I should learn how to do that. So I've taught myself how to do every single letter of the alphabet. So I'd like you to challenge me. Let's keep it simple. Let's stick to something like a 4-letter word. Now choose carefully. If you want to choose a 4-letter word, and if you want, you can have a think about which letters might be easier or more difficult to do than others. If you want to carefully choose a word. Yeah,
I was. Do you want me to pick? Do you want me to pick easy letters? Do you want me to pick difficult letters?
I don't mind. I can do them all.
Okay. I'm going for one that's. It's got 4 letters, and I think most of these letters should be fairly easy.
Okay. What would you like me to do?
Oh, do you want? You're not going to guess the word.
Tell me that. I'm not going to guess. I'm not that level of magic. Come on.
So coat. COAT.
Okay, I will begin folding up bits of paper in order to make the word coat. And in the meantime, I'm going to set you a little challenge.
All right.
Because one of those letters that you've given me to do is the letter T. Yes. It's also the first letter of your name and the last 2 letters of your name. I reckon that it's a nice little puzzle to try and work out how to fold and cut the letter T. So if you want to get your piece of paper, have a go, see if you can figure that one out. And we can see at the end whether you've successfully managed to do that.
I mean, the answer to that is going to be no. Can I get any?
I mean, one thing that might help, this is something that helped me in my early days, was if you sketch out the shape on the paper, you can see the lines and see where you're folding them.
Yes.
So I might just switch to my table cam here so you can see the bits as I've folded them up. That's the 2 bits that I've folded so far. Go on.
So you're cutting a T out. So that's actually fairly. That seems fairly simple. Does it have to be in the center? It has to be in the center of the paper, obviously.
Yeah.
So I mean, in theory, I mean, if I cheat, is this paper square?
It doesn't have to be.
Okay, so I can cheat and move to A4 portrait.
Yeah.
Which means I need to cut out this section here very roughly. And
are you going to make use of the edges of the paper in order to?
Yes, I am.
Okay.
Is that cheating? Don't know. Don't care.
Yeah, that's fine. You've met the brief.
So it's got to be symmetrical as well. Now, very handily, I use a Sharpie there, which means that you can see just about on the back of the paper what I need to cut out.
Yeah.
I mean, that is cheating, really. Because that's 2 cuts, isn't it? I can't go there and there. That's 2 cuts. So
you're allowed more folds.
I am. How do I fold a bit of the paper out of the way of the scissors?
Well, if you're going to cut off the edge,
diagonal
kind of doesn't matter. So you want some kind of diagonal. Can you see the line?
Yes. Hang on. I'm working this out. Because my brain just twigged that the way to avoid having to do a turn is to do a diagonal. Okay. So if I fold down like that.
Okay. The line is lying on top of the other line.
I think that, yeah. I mean,
hopefully.
That was freehand drawing, so it's more like there's sort of 4 lines that are vaguely in the same area. And I make sure that's as close to 45 degrees I can get it freehand. It's about 46 degrees that it should do. And
okay. And then 1 straight cut.
I think if I do 1 straight cut down here. I'm really skeptical about this.
Feel confidence in your solution.
Hey! That is, in hindsight, incredibly easy. But now I see what you mean about the whole recreational mathematics thing, because there was this little spark in my head when I went, oh, diagonals. Like this tiny little, this like elementary school level jump compared to what everyone else on this screen is going to be doing. Of going, how do I avoid making the, how do I avoid having to turn the scissors? Oh, I can turn the paper with a diagonal fold. That was really nice.
Yeah, that's good.
Now, was that the optimal solution? Is there a better way of doing that?
If you're going to do the T out to the edges of the paper, then that is exactly how you would do it. So you can fold it in half. You've got a nice line of symmetry down the middle, and then you just need to take out that kind of chunk in the corners. So I've got here, in theory, the letters of the word coat. Okay. So we'll see if I've been successful here. So I'm going to cut each of these 1 straight cut down there. So that's 1 cut there. That one is the letter O, hopefully. And no, that's okay. There's a hole in an O, so there's supposed to be an extra bit. Good. This one hopefully should be an A if I've done that one right. And that one should be a T.
Good nail polish.
Thank you. I knew I was going to be putting my hands under a camera for 24 hours, so I thought I would make the effort. Okay, so that is the letter C.
Yes, it is.
So that hopefully visible on there. Yeah, fine. And that's, that's sort of straightforward-ish. I've gone, because obviously we're only allowed straight lines here, I've gone slightly square on the O, so that's what
fair.
The O looks like.
All typographical.
And also you can do things with a hole in. Like if your shape, as long as all the edges are straight, even if it's got a hole in the middle, you can still do it with 1 cut because you just kind of fold the other cut that you need to do onto the same place. That is an A there. Hopefully, yeah, that looks like it's worked. And then this is my letter T, which is now made a lot less impressive by the fact that you've just successfully done the letter T over there. But
yours is a little bit better there.
The thing that I've got that you don't necessarily have is this other bit of paper, which has got in it a hole in the shape of the letter T.
That's
you
nice.
Literally just cut along the edges of the shape that you're interested in. So yeah, it's a mathematical theorem. There's a proof of this which says any shape is possible theoretically, as long as you can do enough folds. Even if it's got more than one bit to it, or it's got holes in it, or anything like that, you can do that. And the way that you prove a piece of maths like that, because you sort of think, how do you even start to prove that? It's what's called a constructive proof. So the idea is, if the statement you're trying to prove is this is possible, then all I need to do is give you instructions for how to do it in any kind of situation. So if I give you give me a shape and I can tell you what the fold pattern would be for that, that proves that it's always going to be possible, because my method will always work. And I say my method, it's not my method at all. So this is, for these ones, I've worked out how to do these. I spent like 6 hours in a hotel room in Exeter just folding bits of paper, and came out of the room confident that I could do the whole.
Have you memorized all the patterns?
Yeah, I've got them all in there. They're all in there. Every time I do this, I have to spend about half an hour beforehand practicing S and R, because they're the really difficult ones.
I did wonder whether I should put in one letter that was particularly tricky.
Yeah, I mean, I'll fold an S while I'm talking, just so that you can see how that all works. But yeah, the method that they've got is it's sort of a computational thing. So you get the shape and you look at where all the lines are. You look at where the angles are between lines that join. And there's a couple of different ways of doing it. One of them is called the straight skeleton method, which involves drawing sort of bisectors of all the lines everywhere and finding the halfway points between the corners and things like that. And there's another one where you put a circle at each corner and then let the circles all get bigger at the same time until they touch, and that tells you the points where you need to put the folds through the lines. It's a lot of kind of folding halfway through an angle so that the line goes on top of the other line, or folding halfway along the line so that the line folds back onto itself. So lots of diagonals and lots of lining bits up so that they're correct. So that is hopefully my S.
That just looks like a regular trapezoid.
No, I know, they fall down really small. And if that has
trapezoid? I just realised I've never said that out loud since I was in about 11th grade.
S.
Hey.
Yeah. So now because someone has pointed out in the chat that the letter T is fully 1/3 of your name. So now you've got another one. You're getting closer. We've got a C and an O. So in fact, we've done all of it now. So I'll put that back on the. There you go, Tom Scott. There you go. We just need an M, don't we, for the other one. And N is quite nice because it's got like lots of nice symmetry as well. But yeah, essentially, once you've got this construction method, it's a machine, and you can feed in a thing and it will give you out a thing. So the mathematician that did this was a group of them that I think are all related because they all have the same surname. It's like a father and son and brother group called Eric Demain. In America, and Eric Demain has a really nice website where he's put loads of like printable PDFs of fold patterns that you fold it up and you cut it and it's a turtle or this, that, and the other. And
so the lines don't have to be vertical or horizontal, presumably.
No, you can do diagonals as well. You can do. Yeah, you can basically do any shape at all. I'll just quickly fold the letter D while I'm talking, because that's one of my favorite ones that has diagonal lines in it for the alphabet. But yeah, they talked to me because they heard that I did the letters of the alphabet, and they were like, oh, we should do a font. This is one of Eric's hobbies, is putting together fonts. So he's done all kinds of different fonts. It's like a juggling font where you juggle each letter of the alphabet and stuff like this. And he said, I want to do a fold and cut font. So he's asked me what my fold patterns are for that. And in fact, a couple of months after I started doing this, like I prepped all of this stuff and did this demo for a show. And I got an email from someone that said, oh, really great work on the demo that we saw you do. And I found the PDF that you used for the alphabet. And I said, what PDF? And they'd found someone had already worked out all the fold patterns for all the letters of the alphabet and put the PDF out on the internet. So, that's what I send people now if anyone asks me any serious questions about this. But that is, fingers crossed. There we go. Oh, I've just got a tiny little bit where I've missed. But anyway, that's how it looks when I do the letter D. So that one's, I've just slightly missed there, but otherwise that's got kind of diagonal corners in there, and it's just whatever the angle you want, the fold has to go halfway between. But yeah, and this is one of my favorite puzzles to give people, like, how do you fold this shape? How do you fold a square with a square hole in the middle? how do you fold a square with a diagonal square hole in the middle? That's much harder.
I was going to say square with a hole in the middle. I think I can. I think I can work that square.
It's a nice sort of. That's the nice sort of next step on from like hole shapes. A simple thing with a simple hole in the middle is the next step, and then from there you can build more and more complicated things. The most complicated thing I've ever done with this was I did a full-size silhouette of myself. So I managed to. I took a photo and got the shape of me kind of standing against the wall, and then scaled it up to my actual height. And then I got a big paper tablecloth, folded it up. I did all the folding beforehand, but then I came on stage with this folded up bit of paper, and I just got the scissors and made one massive cut all the way across the whole thing, and opened out this full-size paper steckles, which was quite a fun little demo on the stage. I've still got a couple of folded up paper steckles in the cupboard just in case anyone needs me to do that again. So I made like 3 backup ones just in case it didn't work, obviously.
So square with the square hole in the middle is pretty obviously you do 2 folds and you cut there. Yeah. Square with a diagonal hole in the middle.
Yeah.
All right. So this is where I look. This is going to be such a simple trick that I'm just not going to be able to work out. So it's got to be square. So it's got to be 4-fold symmetry. Is that the right term?
Yeah. Yeah.
I shouldn't have to fold this whole thing again because then I'm going to end up with an octagon, whatever happens. I think.
Yeah, you only need the 2 folds to get the square shape. Yeah.
So it's got to be the angle I do the cut at, surely. But what if? No, because that's the I'm not great at working through my process in my head here because the solutions I keep coming up with are that's fine. Just turn halfway. No, not an option. It's got to be one straight line.
So, like, if you want to, like, I'm trying to kind of work this out for myself here. I'm going to just find a Sharpie because I've got some Sharpies somewhere I can make this a bit more visible. So the thing that I'm thinking is I've got a red bit of paper. So if I want a square, I've folded that in quarters and I know that that's going to give me a square and the sort of diagonal fold there.
I should cheat by drawing a line on here, shouldn't I?
Yeah. But if I want a diagonal hole in the middle, that is going to look like that, right? So the diagonal hole is going to be made up of 4 quarters.
It's going to look like that. No, that's not diagonal. That's not diagonal.
That's the regular square. You want
that's
the diagonal
regular
hole.
One. So let's do a dotted line here. So I need to cut out. It's a little harder to see there, but the dotted line.
Kind of thing. Yeah.
All right. So if I fold this back up,
so I can fold this diagonally and get the simplest possible thing, and I've now just got 2 lines that I need to cut at the same time.
So I was wrong when I said I needed to do that. If I folded again, I'd need an octagon. I'd have to create an octagon. If I fold again,
yes.
This just becomes...
Yeah, it depends the angle that you cut at, because if you cut that line but at an angle, you would get an octagon. But if you cut it perpendicular to that fold, you'll get a diagonal hole in the middle.
So my intuition was completely wrong about that.
Well, it was, this is why these things are difficult. It's kind of visualizing stuff before you can actually see it, but making the actual thing really helps.
But you put the dots on there, showing where you should cut, and it suddenly becomes a lot easier. I suspect that gets a lot more difficult when you have to think more than 1 fold ahead about where you're going to put things.
Yeah, there was a lot of for giant paper steckles. There was a lot of folding and unfolding again, and I'll have to do this bit first, and then I'll put that bit on there, and then because if I do that first, I'll just cut across it, and then I'll end up cutting that bit off. So. And that, that's just painful. So if you want to cut the outside edge and the inside edge at the same time, there'll be a fold somewhere between those 2 that will
back on itself.
That line on itself like that. And then the scissors have vanished. And then that straight cut there, hopefully, that's there. And there is meant to be a hole in the middle, so the fact that I've got an extra bit there is fine. And then I unfold that, and that should have done both outside cut and inside cut in the same cut.
Right.
So
I was nowhere near that. I was a long way off that.
Well, this is I've been doing this for a while now. I'm the expert at folding and cutting, and I have done a number file video about the fold and cut theorem. If anyone's interested in watching, I went to see Brady and he said, "Oh, you can do any letter of the alphabet, can you?" And I said, "Yeah. What would you like me to do?" And I could do Brady, or I could do the the word number file.
He's going to give you something like the Norwegian /O, or like a diacritic above a letter or something like that.
What he actually said was, just do them all. Just do the whole alphabet. And I think his exact words were, this is the most Australian thing anyone's ever said. If you're going to be a bear, be a grizzly. Which is quite a Brady thing to say. But he said, just do the whole alphabet. And he filmed the whole thing, and we put it on as a time lapse in the video, so you can watch me kind of mentally struggling through this entire alphabet one letter at a time. And yeah, so that's gone in the number 5 video. So if anyone's seen that, that's me kind of chatting through the maths behind this as well. But it is genuinely one of my favorite puzzles to kind of pick a shape and go, how would I fold this and cut this? And hopefully you've had a bit of fun with that and twisted your brain around in some slightly interesting ways.
Yeah, I mean, I'm very much on the baby steps version of this, but yeah, there was that moment of insight where my brain just went, oh, and I get why recreational maths is a thing, because when you solve the puzzle, it's lovely.
Yeah, I mean, it's not just recreational maths as well. Like, a lot of this is about sort of nice puzzles that are kind of low-level accessible things, but you know, research mathematicians are effectively just solving quite complicated puzzles. And, you know, the way that people do research maths is they spend 90% of the time bashing their head against a wall. And then every so often they just have this brilliant moment of, oh, yeah, that's how it works. Excellent. And then they can make some progress, and that's how it happens. So I'm glad that you've had a moment of insight and clarity and seen that for yourself. That you've got a sense of how that works, maybe from the inside. Fantastic. Thank you so much for joining us.
Well, thank you very much. You should do the charity plug while
I'll do the charity plug thing. Yeah, I can do that. So I will pop my interstitial video on, since that's the standard thing that happens when I talk about the show. So you're watching the 24-hour Maths Magic show, which is live on YouTube, and we are supporting charities at the same time as Mark Watson's show. So Mark Watson's show, Watsonathon, which started at 9 o'clock last night, just like we did, is also running all the way through. And if I just duck down very slightly, this is the problem with this hat. You see, I can't have the hat on, and but you know, I've got to have the hat on for magic. But this is the donation link, so you can head there, donate some interesting mathematical number of pounds, like a prime number or something, preferably an odd prime number. And that was a maths joke.
I got it. That was good.
It's good. It's a good joke.
Solid.
Yeah. And stick some money on there if you have not already, because that is partly the reason why we're all here. But hopefully this is going to produce a nice, fun bunch of videos that people can watch back afterwards as well. But yeah, thank you so much for coming. And
thank you very much for having me.
Is there anything you want to plug quickly before you disappear?
I'm all good.
I think we've linked to your YouTube channel in the stream. If you've not seen any of Tom's videos, absolutely fantastic YouTube channel, and like stuff around technology and just interesting things, just like the way the universe works, and you really dig into stuff like that. So someone in the chat has suggested someone should donate Graham's number. Which is also a maths joke. Yeah, I mean, please do if you can. I don't think that amount of money exists in the universe.
I was going to say that's.
You know, do like the first few digits of Graham's number. Right? If you figure out what they are, go and figure out what they are. Come back, and then donate that much, or just make something up. It will be fine. Fantastic. Thank you so much, Tom.
Thank you so much. Best of luck with the remaining 14 hours of the show. 13 and a half hours. Give our best to James Grime when he's on. I haven't talked to him in far too long.
That's going to be at some point in the next several hours. We're not giving away too much about when people are on, but I would say if you are maybe having your dinner, that might be a time to see if Tom Scott is to see if James Grime is around. Tom Scott won't be around at that time.
No, I'm gone.
He'll probably be having his dinner. If I'm honest, that's probably what you'll be doing. All right. Thank you so much.
Good to see you. Thank you, everyone. Good luck.